let's look at this numerical in terms of computing the premium as well as going towards the computation of the mortality benefit involved, right? So there is a 20-year special endowment assurance policy, not the traditional one. Let's see why it is special. So the term of this, okay, the type of the policy is special endowment assurance policy. The term of this is 20 years. Age is 45. Each policy provides a sum assured of 10,000 payable at the end of year of death or 20,000 payable if the life survives until the maturity date. So the maturity benefit is 20,000 bucks. Premiums on the policy are payable annually in advance for 15 years only. Premiums are not for the entire period. 15 years only or until the earlier death. You are given the following information. Number of deaths during the 13th policy year, right? So the 13th policy year, we are looking at the number of deaths, actual deaths being 4, and number of policies that are in force at the end of the 13th policy year. So policies in force at the end of the 13th policy year is 195, means in the beginning it would have been 199 before these 4 deaths have occurred. So beginning of the 13th year, this number would have been 199. Now I want to find out the profit or loss that is arising from mortality in the 13th. So for that, again I have to first compute the premium part, right? First compute the premium and then compute the reserves, and based on that I have to compute the mortality profit. Alright, so premium, what should be the premium here? If I am talking about P being the annual premium, A double dot 45, I am anyhow referring to ultimate. So 45 colon 15. This should be equal to the death benefit, which is 10,000 times A 45 colon 20. Again, the death, this is a death benefit, whereas the maturity benefit is 20,000. So 20,000, I can call it as V power 20 P45. So the summation of these two is what is resulting in the premium part. So we can very well compute the premium for this kind of a policy. Alright, let's try out the premium computation part. What is that I require for the premium computation? The first thing is A double dot 4515. Right, A double dot 45 colon 15. If I have to find out, I simply require A double dot 45. Right, I require A double dot 45, A double dot 60. Then I require V power 15, which is depending on 4%, 1 by 1.04 to the power 15. Then I require L60, I require L45. Now all these I can take from AM92 ultimate tables, right? A45 or A double dot 45, 18.823. A double dot 60 comes out to 14.134. Then we have L60 coming out to 9287.2164. Similarly, L45 works out to 9801.3123. So based on this, I can find out A double dot 45 colon 15, which comes out as A double dot 45 minus V power 15 times 20p 45 15p 45, which is L60 by L45 times A double dot 60. So this comes out to some 11.38p. So this is the premium part, right? The total premiums that are paid is 11.38p. Now the same logic, I will go with the expected present value of the death benefit alone, which is 10,000 times A 4520. Now if I had to find out A 45 colon 20 with a term life, it is nothing but A 45 minus 20p 45 times V per 20 times A 65. So for that reason, I can directly take A 45, A 65, and 20p 45 requires L 65 and L 45, and V per 20 is something that is known 1 by 1.04 to the power 20. 1 by 1.05 was 04 to the power 20, which is this much. L45 we have already taken earlier. This is the L45. L65 for the same, L65 is going to work out to 8821.2612. Then I am looking at A45 and A65. A45 is 0.27605 and A65 is 0.52786. Right, so these are the stuff, which means I can very well compute the expected present value of the death benefit, which comes out as 10,000 times A45 minus V power 20 times 20p45, which is L65 by L45 times A65, which is expected present value of the death benefit is somewhere around 592. Similarly, I can talk about the expected present value of the maturity benefit. Here it is straightforward, 20,000 times V per 20 times 20p45. So I'll write it as 20,000 times V per 20 times 20p45 comes as L65 by L45. So this is the expected present value of the maturity benefit. So based on this, I can very well compute the overall premium that is required for this. Right, I could very well compute the overall premium that is needed for this, which will give me the summation of the maturity benefit plus the death benefit divided by this number is giving me that the premium is somewhere around 773. Right, the premium I have got it as 773. Here I did not take any expenses or anything, it's purely a net premium. Alright, so this is what is the premium. So I now need to go for the 13th year. So for that, I have to compute the reserves at the end of 13th year. Now how do I compute the reserves at the end of the 13th year? Whatever is the death benefit or whatever are the benefits that are yet to be paid. So the death benefit will be A58. By the 13th year, the person's age will become 58. A58 colon 7 would be the death benefit. So 10,000 times A58 colon 7 plus 20,000 times V power 7, 7p58 is the maturity benefit. And out of this, the premium, the present value of the premium minus expected present value of the premium, whatever the premium we have computed, we have to still pay for 2 more years, 58:2. So this will give me the reserves, right? This will give me the reserves at the end of the 13th year. So for this I require all these calculations. So A58.7. So probably here I still require A double dot 58, A double dot 60 is there with me. Right, so A double dot 58 I require. Similarly, L58 is what we require. L60 is already there. And then I also require V power 2. 1 by 1.04 to the power 2. So at least the expected present value of the premium I can directly get. So which is whatever is the premium amount times I have to compute. I have to get these values. A double dot 58 now. A double dot 58 for me is 14.847. 14.847, and even L58 is somewhere 9413.8004. So based on this, I think I should be able to compute the expected present value of the future premiums to be paid. So this number times A double dot 58 minus V squared times 2p58, which is L60 divided by L58 multiplied by A double dot 60. So the expected present value of the premiums is going to be this much. Similarly, now I can find out the first part, A58:7. So for that extra I require A58, I require V power 7. So 1 by 1.04 to the power 7. And L58 we already have. Right, L55 we have, L65 we have. So I think I can find out the expected present value of the death benefit once I get the capital A58. Capital A58 is 0.42896. Okay. Now here I am computing the expected present value of the death benefit directly, which is 10,000 times A58 minus V power 7 times 7p58, which is L65 divided by L58 times A65. A65 is here. So the expected present value of the death benefit is coming out to 530. Similarly, expected present value of the maturity benefit is going to come out as 20,000 V power 7 7p58. So 20,000 V power 7 7p58, which is L65 divided by L58. So this is expected present value of the maturity benefit, which means I could compute the reserves at the end of the 13th year, which is expected present value of the different benefits minus the expected present value of the premiums. So the reserves are coming out to some 13,260. Now these are the reserves, which means now I can look at the death strain at risk, which would be the sum assured minus the reserves built until that point. Sum assured, we know it is 10,000 in case of death. So the reserves are already higher compared to the sum assured. Means the company has already built up sufficient amount of reserves to cater to the payment of these particular policies. So if the death strain at risk is negative, if there are early deaths, there is a profit, right? If the actual deaths are more than the expected, the company is making a profit. If the actual deaths are lesser than the expected, it's going to be a loss. Even if I look at the expected death strain, okay, so initially the death strain is this much for each policy. Now multiply it with the number of policies, multiply with the probability of death. Now what is the probability of death in that particular year, 12 to 13? So I need to go with Q57. Right, I want to see what is the Q57 number associated with the possibility of death. So I'll take it as 0.00565. So expected death strain is going to be somewhere around this, whereas actual death strain, there are 4 deaths. So for each policy, this is the death strain, and actually there are 4 deaths, which means the actual death strain is this much. So from here I can talk about the computation of the mortality profit, which goes as the expected death strain minus the actual death strain, which is giving a profit of 9,375 bucks. So if more people are dying compared to the expected, there will be a mortality profit. If the death strain is negative, more people die than expected, there is a profit. If the death strain at risk is positive, less people die than expected, there is going to be a mortality profit. So that's how we can step by step wise compute the mortality profit. But in this case, the important learning for us is the scenario one where the premiums are paid for a certain period, whereas the policy is for a certain period. And we are also looking at the mortality profit computation, especially when the death strain at risk is turning out to be negative. All right.